everybody, welcome back. We're going to be going over 9.3, which is a review of radicals before we begin Unit 8. This should be a review, not new information. So if you're having struggles with this, you might want to come into conference period at some point, okay? So first of all, just to review some properties of radicals. Remember, the product property says that if I have a radical that has two terms multiplied together, I can separate those two radicals as long as they have the same index into the square root of a times the square root of b, or this cube root of a times the cube root of b. Same thing with my quotient property. If I have a quotient of some term divided by another term, I can separate those into two separate radicals as long as they have the same index. And I can go back and forth. I can go this way or this way. So I can put it together under the same radical. Okay? So let's say, what is an equivalent expression of the square root of 63? I'm going to take my square root of 63 and write it as the square root of 9 times 7. Oops, 9 times 7. I want to look for perfect square factors that are a factor of 63. In this case, it would be 9. So I can split this up into the square root of 9 times the square root of 7. And then the square root of 9 is 3. Don't put the square root again because that's already been taken care of. So the square root of 3 times the square root of 7. So this is an equivalent expression as the square root of 63. It's simplified, and we don't have any more perfect square factors other than just 1. Okay? Next, we're going to look at the square root of 44. So you go ahead and try this on your own and then see how you do. Okay? So the square root of 44, this is going to be the square root of 4 times 11. So 4 is a perfect square factor that goes into 44. And then we can separate these up to the square root of 4 times the square root of 11. The square root of 4 is 2. And then we have left the square root of 11. We can't take the square root of 11 without decimals. So that is simplified. It doesn't have any more perfect square factors in the radical except for 1. Okay? So how about this guy? This is multiplied, right? So this is 3 times the square root of 27. Perfect square factor that goes into 27 is 9. So 9 times 3. And then I can separate these into the square root of 9 times the square root of 3. Then the square root of 9 is 3. So that becomes 3 times 3 times the square root of 3. So keep in mind that this is the square root of 9, right? That becomes 3. Okay? Then we multiply those together. So 3 times 3 right here is 9. And then we're left with our square root of 3. So it's 9 times the square root of 3 is that simplified. Okay? So now let's add some variables into this guy. So rewrite this expression to remove perfect square factors other than 1. And now we're going to add variables. So the trick I like to remember is, since this is a square root, we take the square root of a variable by dividing by 2. So I want to think about what's the next highest power of x would be divisible by 2. And that would be the 8th power, right? So again, 63 would be 9 times 7. And I'm going to write x to the 9th as 8x to the 8th times x. Okay, because 8 divided by 2 would give us the 4th power. Okay, and so now I'm going to have this is a perfect square factor, and this is a perfect square. Okay, so I can separate these into the square root of 9 times the square root of 7 times the square root of x to the 8th times the square root of x. Okay, the square root of 9 is 3. The square root of x to the 8th, again, I'm just going to take my 8 divided by my index, which is 2. So it's going to be x to the 4th power. And think about it the other way, x to the 4th squared is going to be x to the 8th. Okay, then I have what I have left here, x to the 7th times the square root of x. Or sorry, square root of 7 times the square root of x. So I'll put those together as 3x to the 4th times the square root of 7x. And that is all simplified. All right. So let's give you 2 practice problems to try with and come back and see how you do. Square root of 25, that's already a perfect square. And the next highest power here that's divisible by 2 is x squared. So I'll break this up into x squared times x. So that will be square root of 25 times the square root of x squared times the square root of x. The square root of 25 is 5. The square root of x squared is x, and I'm left with just my square root of x. So I have 5x square root of x, and that is simplified. Okay, let's look at this one last one here. We already have 5 on the outside. 4 is already a perfect square. My next power that's divisible by 2 is x to the 16th. Then times x, so that will get us to our x to the 17th. So we have 5 times the square root of 4 times the square root of x to the 16th times the square root of x. That's 5 times 2. And the square root of x to the 16th would be 16 divided by that 2, which would be x to the 8th times the square root of x. Now we just have to simplify. 5 times 2 is 10. X to the 8th times the square root of x. And there we go. Okay, so that's what we're focusing on today, is just being able to simplify those radicals. You're going to have an Excel in Google Classroom, and then we will focus on multiplying and rationalizing on the next assignment. Okay, I'll talk to you later, and have a good day. Bye-bye.